Okay, we're going to talk a little bit about rockets and orbits, and this is kind of fun because there's been a lot of this in the news lately. And in order to talk about rockets and orbits, we need to talk a little bit about momentum and projectiles and a little geometry, and of course, some ideas of force. So we're going to start off by reviewing some conservation and momentum ideas. I want you to kind of imagine that you're standing on a skateboard and you're standing still, and for some strange reason you have a ball in your hand and it's heavy enough that it's a 5-kilogram ball or so, and you're going to throw it forward. And when you do that, if you think for a minute, when you throw that ball forward, if you're standing on the skateboard, you roll backwards. And so this is the idea that helps us understand how the rocket takes off and keeps moving. At the beginning, with you standing on that skateboard, holding the ball, your momentum is 0. When you throw the ball forward, it's moving and you're moving, but the sum of both of your momentums still has to be 0 because the momentum before has to be equal to the momentum after. And so what you end up with is forward momentum because one object is moving one way and the other object is moving the other. And so here's a mathematical example real quick. If you go ahead and plug in the math for this, and so before you have the mass of the skater and the ball, and the velocity of the two things stuck together is 0. And then afterwards, we have the mass of the skater, and we don't know what the velocity of the skater is, but we do know that we have that ball that's 5 kilograms, and we threw the ball at 10 meters per second forward. And so momentum before is equal to momentum after. And so you set up the equations, mass times velocity of everything all stuck together is equal to the mass of the skater and the velocity of the skater multiplied together, plus the mass of the ball and the velocity of the ball multiplied together. So 70 times 0 is going to give us 0. And then we have the mass of the skater times its velocity, which is what we're hunting for, and then the momentum of the ball. And when you work it all out, you end up with a velocity of the skater at 0.77 meters per second negative. So skater's going backwards, ball's going forwards. Skater's much larger than the ball, so the skater's moving slower. So when you get the idea that when you have a rocket launch, the exhaust has a really large velocity. So in your mind, picture one of the rocket launches, all that fire and steam and water shooting out. Very large velocity, but it's much smaller in mass than the rocket. So the rocket has a huge mass. It's going to leave that platform at a very, very slow rate, but it does leave. So kind of work all this in your mind a little bit, put that piece there, and let's apply it straight to the rocket. So rocket starts off at rest on the launch platform. There's a chemical reaction in the engine and it creates hot gas. The hot gas leaves the rocket. It has a backwards or downward momentum, which forces the rocket upward. And then the rocket, as it goes up, the rocket engine continues to push backward on the gas, and the gas pushes forward equally on the rocket, and so it keeps climbing. So as it climbs, it moves into something called an orbit, and an orbit is a path that's followed around another object. So if you're moving around an object in a circular or elliptical path, that's called an orbit. And what's creating that orbit is gravity, pulling that rocket inward with a centripetal force, kind of holding it in and making it go in a circle. But the rocket has enough horizontal velocity. So remember at the beginning of this, I was talking about projectiles. Here we go. It has enough horizontal velocity that it doesn't hit the Earth, but it follows the curvature of the Earth around. And it's always falling, but the Earth is always bending away from it. And one of the things that you'll hear when you're talking about orbitals is the orbital period. And that's just the time it takes for that object to go around the full circle one time. And so here's just some little details about Earth orbit when you're watching the news. A low Earth orbit, you can get around the Earth in 84 minutes, which does seem pretty quick. There's something called geosynchronous orbit, and that just is where a lot of the satellites are parked so that they stay in the same place. So if you have, satellite radio, you always want that satellite to be in the same place. You don't want it moving around, because if it went around to the other side of the Earth, it wouldn't do you much good. You want it to be at a radius that creates a period that is a full day, so that it stays basically in place relative to the surface of the Earth. And if a rocket has enough speed and enough energy, it'll go out farther with a larger radius, and it does become a more elliptical orbit. If that speed that the rocket has is greater than 11.2 kilometers per second, and that's kind of an average value, we say it has escape velocity, and that would take it out of Earth's influence, and it continues its path until some other large object acts on it with its gravity. All right, so that's a little bit about rockets and orbits. Bye-bye.